Okay. Morning, everyone. So I know many of you are in the mood of the long weekend. Probably after today's class, you rush to the beach or
Not today.
not today, tomorrow, right? Yeah, I checked the weather. It's not very good. Unfortunately, I will also go to the beach, Outer Banks. The weather, the weekend is also very good. But anyway. As long as you have reserve, you have to go. Right? Yeah.
Maybe tomorrow.
Maybe we can find some indoor pool. That's okay, right? Have fun. So, okay, let's finish today's class and then you can enjoy the long weekend. Just remember, don't come here next Monday. I won't be here. Right? Don't complain if you don't see me next Monday. Okay, so we have finished several different models for forecasting. I want to ask you guys, okay, what's the models we have covered for forecasting? The first model we have covered. What's the name of the first model? LaIU model. LaIU model. Anything else after LaIU model? Moving average. Very good. After moving average?
Weighted average.
Yeah, weighted average. So, all of these are belonging to the big family called the time series model, right? The reason it's time series is because we use the historical data to build our model to make this forecast for the future. That's a time series model. Okay. Now, today we will introduce the next model. It's called exponential smoothing. It's also a weighted averaging method based on the previous forecast plus the percentage of the forecast error. So here's the formula. Ft equal to Ft minus 1 plus alpha is the parameter or percentage. Times the forecast error. We have learned the forecast error, right? So it's actual minus forecast. This is the formula. Ft is the steep willing forecast, such as lax period forecast or demand forecast. Well, A is the actual sales, or should be ideally actual demand of this, right? Ft minus 1 is what we have done last period. We make the forecast of this period. Well, so Ft minus 1 most likely has some error compared to At minus 1. So its error times the percentage. Alpha usually is from 0 to 1, 20%, 30%, 90%. Usually alpha is from 0 to 1. Right? So this is the formula of exponential smoothing. Before I go deeper to explain this formula, let's think about two extreme cases. Well, when I was in mathematical school, right, many times when you want to prove some theorem, you always think of extreme case. Say, okay, like two parallel lines never intercepts with each other, right? So you want to think about extreme case, right? Or let's say a triangle, add them together is 180 degrees. You want to get some extreme case, or just give some example to test whether it's true. Let's think about this formula. Okay, extreme case. As I mentioned, usually alpha is between 0 and 1. Let's see what's happening if alpha equal to 0. Who can tell me how this formula will change when alpha becomes 0? Ft equal to Ft minus 1. Great. What does this mean? What does this mean? If we use this method, what will happen?
We're not going to make any changes to our forecast.
Yeah, you are so lazy. You make one forecast and use this forecast forever. Right? Well, we never introduce any forecast method like this because it's not rational, right? But you can do that. Well, so then you know that this alpha equal to 1. Another extreme case, alpha equal to 0, alpha equal to 1. Who can tell me what will happen when alpha equal to 1? Very good. John has mentioned, right? Equal to At minus 1. What does this mean?
Actual last period.
Are we familiar with this one?
The actual value of last period.
Dan?
Forecast of this section equal to the actual product.
Yeah, actual. Dan, are we familiar with this one? It is.
The stable.
Huh?
Is it stable time series?
Stable time series. We don't have this like stable time series model. Yeah, it's a stable time series. Are we familiar with this one? Have we learned this one?
Is that the naive?
Yes.
Naive forecast?
It's naive method. Right? It is nothing but naive method. Use last period's actual demand to make the forecast of next period. What is naive method? Then what's happened between 0 and 1? You know the trend, right? So you can see when alpha equal to close to 0, our forecast, majority of our forecast is based on last period forecast, right? Close to 0. When alpha becomes larger and larger, our forecast, the majority of our forecast is based on last period actual demand. Right? So what's happened when alpha between 0 and 1? That's the weights you change, right? You put more weights on last period forecast until more, until you put more weights on last period actual. Anything between 0 and 1, you have the weights. Right? If we write this differently, which is alpha at minus 1 plus 1 minus alpha, you can see this weight, ft minus 1. Then maybe this is clear for you, right? So it's weighted, right? Alpha 1 minus alpha. You choose the weight. How much weight you want to put for actual, or how much weight you want to put for the previous forecast. Two extreme cases, right? You can see that. Well, definitely for most situations, when we talk about exponential smoothing, alpha not equal to 1 or 0. Alpha is something between 0 and 1. So now you understand why it's a weighted average method. Right? It's weights between your last period actual demand and last period forecast. Then definitely another thing I can teach you is that how to choose alpha. In homework exam, alpha is given 20%, 30%, 40%. Well, how to choose alpha? It depends on you. For example, if you think it's very stable, your demand is very, very stable, you don't need to change your forecast too frequently. Then you put small alpha, right? The majority of the weights is on ft minus 1. You think my forecast is the first forecast we get. We build a very fancy model. It takes us a lot of time. Try this forecast. Well, give more weights on the previous forecast. On the other hand, you think, okay, there's some fluctuation. Well, the actual demand happened last period really have very strong relationship with what will happen next period. Then you put alpha larger, like 70%, 80%. Then you have more weights on the previous actual demand. So that's the way you choose alpha. Clear? Question? Comment? So this is the weighted average. You know that. Okay. Which one you think is more important? Put more weights. Okay, that is the formula. Let's give a very simple example. And it's very simple practice. Okay, so period 1, 2, 3. Actual forecast. Okay, so let's say 20, 21, and then alpha equal to 0.3, 30%. So now the first question, we want to forecast period 2. Right? Small exercise. What is the value we get? Actual for period 1 is 20, forecast 21. Alpha we have already determined is 30%, 0.3. Then my question is, what is F2? Forecast for the second period. I just plug them in to get that, right? 20.7. How do you get that? It's 21, right? Plus 0.3.
And then times the
20
error 21
minus 21. So this becomes negative 1, negative 3. So it's 21 minus 0.3. So you will get, that's what you get. Okay, 20.7. Right? So you get 20.7 is the forecast for period 2. Right? Okay, let's say it's a weekly forecast. After this week, we realize the true demand. Okay, then we find true demand is 22. No surprising, that must be some forecast error, right? 22. Now, I'm the manager. Give me the forecast of period 3 using the same method. F3. So it's step by step, right? First forecast period 2, and then later you realize the true demand, and then you calculate the forecast error, then you can move forward to calculate the forecast for period 3. Anybody? Guess the result? 22 plus 22.3 line, right?
29.
Yeah. So do the same thing. F3 is equal to, so that's the formula. F2 plus alpha A2 minus F2. Right? F2 already got is 20 plus 0.7 plus 0.3 times 22 minus 20.7. So we get 20 plus 20.7 plus 0.39. Okay. Yeah. So you finally guess is 21.09. Is that right?
21.39.
That's right.
Yeah, that's right.
That's right. Yeah. So you can see when you use this method, right? Always you first make a forecast for next period, but the forecast you make has very strong relationship with the next period forecast because next period forecast is related to the previous forecast. So it's moving forward. It's good. Good. Check. Good. Okay. That's the sequence smoothing method. Okay. Next, we'll talk about the techniques for trend. Now, we have talked about time series model, like naive, moving average, weighted moving average, expansion smoothing. This model is very good to capture stable pattern. When you have stable pattern with fluctuation up and down, all this time series model can smooth your fluctuation or variance, okay, to make the forecast. So you can see like moving average, okay, it's a very stable forecast. It can capture trend, but it's very stable forecast. But if you really have very strong trend, well, I won't recommend you to use any method we have talked about before. Even naive method with trend, you can capture, but those are the best method. Now we'll talk about trend. In this class, we'll know how to use the linear trend equation to make our forecast. Basically speaking, it means if our historical pattern follow linear pattern, right, straight line, then we'll study how to build a model and how to use model to make a forecast. But some other non-linear trend we're introducing here, but we won't teach you how to build a model. Right? This can be complex, but you can learn that later when you go to graduate school. It's not so hard. So for example, like parabolic trend. For example, this trend can be if your demand is something like that, y equal to 3 plus x minus 3 squared. Something like that, right? How to guess this picture. So if you have like quadratic function, okay, you have something like that. Right? Here is life cycle trend. Think about products. When it's just entered the market, the demand is pretty low. When they go up and up, become more and more popular, become increase, and enter the mature period, right? So it's in the peak area, and then finally fade away from the markets, and finally exit the market. So it's life cycle trend. Exponential trend, beginning is very strong, and then become less and less popular, something like y equal to 1 over x, exponential function. And the growth curve, well, first very stable and increase sharply, and then keep stable. Okay. So all these trends we have seen here, they are not linear. Clear? Agree with me? They are not linear, right? Because linear should be a straight line. Well, some are just pure decreasing or increase trend. Some trend like sometimes decreasing, sometimes increasing. Right? Well, it can be very complex to capture. Right? But as long as if you figure out the function can fit your historical data, and then you can use this function. It can be a hard function, right? X squared, x cubed, or 1 over x. But if you can fix the function, you can use this function to make a forecast. The general idea how to make the forecast. That's we won't teach here. What we will teach is linear trend. Linear trend is that if you find, say you find your office supply and demand in Walmart, something like this, the past 4 weeks, right? Then you can see these 4 points, and they are very close to these straight lines. Very bad, sorry. It's very close to this straight line, right? These 4 points. Okay, now we think about, okay, it's better, I mean, it's good to build a linear equation, right, to fit the historical model, and to use this linear equation to make the forecast for the future. That's the linear trend. It's clear? Clear for you? So before we can jump to this model, okay, the first thing is to plot the data. It's not just for linear trend or some specific model. Any model, before you choose them, like EU moving average, okay, you should plot data. You should plot. We have a homework, or ask you to plot. Right? But some homework or some example will just give you, okay, use moving average, use linear trend. But think about in reality, when you work in the company, well, your manager, if he knows which model to use, why he wants you to help you to do that, right? So most likely you will have to figure out the model. Sorry. No? Okay, you will have to figure out the model, then you have to plot. I learned that when I was a student, when I was a little bit older than you, the first graduate level statistics class I have taken when I was in Purdue, well, I still remember my teacher. She's from Canada, and she teaches us how to use SAS to run the linear regression. A lot of MANOVA, you know that, those MANOVA, ANOVA, right? So use that to analyze the statistical results. And when she taught us how to run the linear regression model, first thing she always tell us, the first thing you will do is always plot. Before you jump to any model. Well, that class, we focus on linear regression model. We didn't talk about like quadratic explanation model we have looked at last page, right? Sept, actually here, right? We talk about linear regression model. Everybody knows that we have a very strong assumption. If you test me, it must be linear regression model. But this is just for class, right? You know that in the exam. I can't give you some explanation model to let you try to build a model. You know that. 100% it must be linear model. But this is just for our class. You remember, if you go to industry, you can't have this assumption. This assumption can kill you. If you have this assumption, I only know linear regression, I only know linear trend, this can kill you. Don't have any assumption, right? But you can plot the data, plot, and then find a pattern. If here is a linear pattern, then go ahead. You already have the weapon here. If you, from the observation of the plot, you find it's really a linear pattern, then we can try to build this linear trend model. Well, Ft is equal to A plus Bt, which means your forecast of period T depends on your period number. Which week, which day are you in? So Ft is the forecast of period T, and the A is the value of Ft as T equal to 0, or you from statistical, you know it's easy to understand. A is the intercept, right? It's the intercept of the linear equation. And B is the slope of the line. T is the time series, right? It's the specific number of time period from T equal to 0. How to calculate the parameter A and B? Well, this affects the quick review of what you have learned in Statistics 2 class. I think Dr. Kang or Victor or Fisher, I don't know which faculty they have taught you business statistics too, but I can guarantee they must teach you how to calculate that. Let's have a review. So to calculate the A and B, first we'll calculate the slope of this linear transfer function. So the slope B is equal to, let's first look at the numerator, n. N is how many samples you have, or how many observations you have to build a model. For example, use past 10 weeks data. Use past 10 weeks data to build the model. Then, what is the value of n? 10, right? Use 10. If you use past 20 months week data to build a model, then what's the value of n? 20, right? So n is just your sample size, or how many data points you have used. Summation ty, well, which means t is the time series of 1, 2, 3, 4, right? For each time point, like here, right? T equal to 1, 2, 3, 4. That's corresponding value of y, like sales data. Right? It can be 20, 25, 30, 35. Then we know, okay, for t equal to 1, what is the value of y in this example? T equal to y. What is the value of y? 20, right? When t equal to 2, the value of y is equal to 25, right? Then you just multiply them together, right? T equal to 1, y equal to 20, 1 times 20, and then plus 2 times 25, plus 3 until n, right? This side. Minus sum t, right? It's just 1 plus 2 plus 3 plus 4, right? Plus whatever you have, right? T equal to 10 or 20. Summation of y, the same thing. For each value of t, it's 20 plus 25 plus 30 plus 35. That's the numerator. The denominator, the first term is n, we still know is sample size, times summation t squared, which means you first square the t, 1 square, 2 square, 3 square, right? 1, 4, 9, 16. And then sum them together. Minus, okay, some students get confused here, right? Minus this the bracket here, so you first sum t together. So it's 1 plus 2 plus 3 plus 4 together and square. So they are different. Once you get B, A can be straightforward. Either you can use the first formula, summation y minus b summation t divided by n, or I do recommend you choose the second one. It's easier. You get the average value of y. Y bar is the average or mean of y, right? Gets average. 20 plus 25 plus 30 plus 35 divided by 4. Minus the b value you already calculated first, times the average of t bar. Then you will get A. So it's pretty tedious to talk about the formula, and I guess still some of you are still confused about this formula. But first, write down this formula because we have example time. If you don't have a formula, can't do the exam. Right? If you finish copying this formula, then we can move to the next slides. We have give you a long time, right, to do the exercise. Because I can guarantee you will have something similar in your exam, right, for linear trial. So you have to know how to use your calculator to calculate the A and B. Well, some students say, oh, it's pretty easy if we can use Excel. I understand that. Well, you put it in Excel, you don't need to know the formula. But the problem is that we have to try to do it by ourselves at least like 3 times, I would say. Then you can trust Excel or any software. Otherwise, don't know how to do that. Right? That's like a magic. Not really magic. Rocket science, in fact. Everybody gets the formula? Everybody? Formula? Make sure everybody gets the formula. Don't point finger to others. I want to make sure everybody gets the formula. You get the formula.
I got it.
Yeah, that's very important.
It's in my notes.
Okay. Example. Here's the example. So, cell phone sales for California-based firm over the last 10 weeks are shown in the table below. Week 1, 700. Week 2, 724 until week 10, 775. First, you should plot the data, but, well, I don't want you to spend a lot of time to plot the data. But just look at this number. Which trend do you think is for? It's increase trend, right? Well, I can tell you, okay, you don't have to plot, but in the homework, you probably want to plot by yourself. But it's follow the linear trend. It's a linear trend. Yeah. But ideally speaking, you should plot. Right? So 10 weeks is increase trend. We can say plot the data. Well, you can plot, but to save some time, maybe notes in the class. And visually check to see if a linear trend line would be appropriate. Then, that's our task now. We want to determine the equation of the linear trend and forecast the sales for week 11 to 12. So, I would suggest you do something similar to me. Right? You have the table, right? So table week sales. You write this as T as Y. T and Y. Okay. So week 1, the sales is equal to 700. Week 2, 724. Week 3, another 720. Okay. The next column I want you to add is something can be very helpful. You don't necessarily do that, but if you do that, I bet you feel more comfortable when you approach this formula. So you can see in the formula something we have to calculate. You can calculate in the middle step, or you can just write down here. Ty. We need that in the first term of our numerator. We did Ty. Right? Some other thing we need to calculate, such as T squared. Right? I would definitely suggest you to add these two columns to calculate. We have T, and we can sum T together. We have Y, we can sum Y together. But Ty, well, we want to calculate for each one. For period 1, what is the value of Ty? 700. What about period 2? 1448. Right? Just use T is 2 times 724. You guess this value. What about period 3? 2160. Very good job. T squared, period 1. T squared. 2 trivial, right? 1. Period 2.
4.
Period 3.
9.
Do the same thing for all the time period. And then it will make your life much easier to plug in the formula to calculate B and A. Okay? Give you guys at least 10 minutes, so you will have plenty of time to do this then.
Oh my god.
What's your
I use my pen.
pen? No other pen?
I use mine. He ain't got no pen. Just say T1.
T times Y. Because in the formula you need T times Y. what we want to have is the formula, right? Is the ft equal to a plus bt, right? And then you plug t equal to 11 and 12, you get the forecast. Right? But first you figure out a and b. That's our goal. So our goal is get the formula ft a plus bt.
So the actual 17.
Then we calculate t and a.
17. Keep going. Keep going.
Is ATB, is that the same as line of best fit, right?
Uh-huh.
Is that the same as line of best fit, correct?
Yeah, because well, you
trying to find the slope and the.
that's right.
and
That's
ah.
right. That's right. So that's the reason I asked you to copy the formula. You I copy that, right?
Oh, so would that work?
So then you need to first calculate slope b and then intercepts a.
So you just do like 7 or xy minus x or yeah, x2 minus x1 divided by
x2.
no
No, you.
or y1 divided by y2 and do like the points or point slopes formula.
Well, this is the same formula. This is the same formula you have learned in statistics class.
Oh.
It's the same formula. But now you in the statistics class use x and y, right?
So
But now
that's-
it's t and y. So
Oh,
t
so
is
now
the
you're just
same.
using time.
Yes, so it's the same. If you look at the formula in your statistics, it's just replace the t with x. Same thing.
Oh,
Okay. Just use the formula we have introduced here. Same thing.
that's not too much work.
Too much work. That's the reason give you lots of time. You'd better practice. Then before in the exam you complain. Exam we only have 50 minutes, 1 hour plus the break time. Just in class exam.
We could just throw that in the calculator too to tell the answer.
No, we have in class exam. So-
Throw it in the calculator.
Should be fine. Those too many questions. Yes. So first go to B. Okay.
Check. All you do is just finish
I will double check for you.
2 rows, right?
Yeah, for the white bar, just sum together divided by 10 in this example.
Yeah, I just did all the columns.
Glad I remembered this.
People grab a calculator.
Batteries are dead.
Mine are too.
Cause you know, you just literally throw all that in, put it just hit, find out line of best fit.
I just give you the example, but you definitely need to also here.
And then before you then go to the point.
Yeah, because you think about summation is from 1 to n. N is 10, right? You have a summation 10 together. Same summation to 10. Take your time, we have plenty of time. Check my notes.
I think that's what he wants.
I think you are. Let's go right next to you.
What is your final results for? I mean, you have to forecast, right? Forecast period.
Yeah.
11 and 12.
Is she?
Forecast.
You're flirting with Keelan.
Yeah,
I'm gonna back
11.
off my boots.
You need to plug them in forecast week 11 and week 12. That's right. That's the reason. That's how we used it.
What do you do?
You guess the formula, and you plug t equal to 11 and 12.
I have no idea.
No. You want to base on the past 10 weeks data. After you finish this model, you get ft equal to a plus bt. Then you plug t equal to 11 into the model, which becomes your forecast week 11. Clear?
I say, I assume you tell me.
Okay.
I need to watch you.
Wash me?
Watch.
Yeah. Wash me.
Just to
Give you a bath like
Yeah, I think that this calculator has
They'll
some
give you a
fancy
bath
model
like
you
that.
can.
and then I got it because I entered everything.
Okay.
I need to see the whole
Better.
Well, I did it here.
You just double check.
Just double
Oh,
check.
that's good. And then you still owe me the final step, right? That's not finished. What's your questions? What's the question?
11, 12.
Yeah, it's easy for you.
Yeah, I don't know. I don't know that the big E is big E. Dina. Big E thing.
The B seems a little bit too B is slow, right? Slow is like
That's the simple
how fast is equal, right? Some others will get something about 7 and 1. I want to double check. I can check. So, so it is
I have no idea.
No, but some weeks, but
Alright.
if you put I'm not gonna add a week, so.
summation T. Okay.
Okay.
Well, double check here.
Right.
181. I don't think it's 181.
We don't get this all down.
Something.
Bless you.
Yeah, 55.
Fine, so you want to send me that?
Yeah, that's the formula.
Oh.
How you do it? So you already have, right? All of them. Get the summation first. Like the last row have, right? You get summation, summation T, summation Y, summation T Y, summation T
So
squared.
you want us to add a week too?
All 10 weeks you want to sum together, right? Because this is T, right? This is 1, 2, 3 until 10. You sum together.
Yeah.
Or you already sum T Y, which is
Yeah.
good. And also, all these 4 columns want to get summation first.
Okay.
Right?
Oh,
Okay. Same thing.
yeah, I heard what you said, so.
Sure.
What's this? 7, 4.
And a little bit too high for me. Let me double check for you. Okay, so it's really hard to check for you. Just give the direct number. Have you checked? Well, I still suggest you to bias the summation here.
Wow, that's a big number.
And otherwise, I can't check which step has something.
How do you know that's not right?
Yeah,
Put
yeah.
the thing at the bottom.
Yeah, some together.
Okay,
Yeah,
well, this one was,
yeah, that's right.
okay, that one.
Don't you check? Maybe that is right. Should be something around 2.1.
You don't want to check one?
No, it's done. Is that done?
Yeah.
Man, God, you got fun slope and all that, bro.
Yeah, that's right.
Oh, you didn't tell me that part?
Wow.
Is that FT slope?
Yeah.
T and Y, right?
No, no, it's
Yeah, this you just add 1 plus 2.
Have you copied the formula?
That one right there, the point.
55.
Oh, we're not gonna use that one right there.
Yeah, no stats formula.
What, FT equals A plus BT?
That's the reason I asked you guys whether you have copied the formula. You don't have formula.
I didn't.
I need to.
Yeah, I did. Yeah, I did.
I thought you were talking about that one. That shit. That's a slope answer.
I And also I print the slides for you. Why is your slide?
What'd you say?
I left him in the car. It was raining. I had to hurry to the class.
Messed it up.
I was trying to beat you here.
Do you think it's it's okay still?
That one should be acceptable. It's raining.
It's my choice to whether she's acceptable. I can accept this time, but since I printed, that's why it's fine.
Yeah, they right there in the
Oh, that's what I was trying to ask.
right there in the passenger seat.
You should put it there.
My book bag. Yeah.
Right.
Oh, you just wrote
Okay.
it.
I definitely expect you to bring the slide. Okay. Sure. Now you won't miss that.
Don't call him Charles. Call him Mr. Charles.
Either way, it's wrong. Should be Dr. Charles.
Call-
Also, it's wrong.
I got 120.
Mine student call. Another thing wrong. I will tell you guys. So when you call some person professional, you should just call the last name, right? Professor Sean or Dr. Sean. Or just call Charles.
Charles.
Yeah, it's easy here.
I'd rather not say it wrong.
No.
I don't like
Don't
people
call you
saying my
Charles.
last name wrong.
Yeah, that's Then use the formula, right? To calculate B.
What is it?
N is 10, right?
Yeah, and it's
And times summation
TY
TY. What
is
again?
that.
Yeah.
We need to use the total.
Yeah, summation TY is the total.
Okay.
Yeah.
So
Everyone
18
always says my last name wrong.
total?
Yeah, yes.
That's not how you say it.
And then-
Skolton.
I did
Have
that
you
on
finished
purpose.
that?
Okay.
She was.
I had the same question. Yeah.
Okay. Okay. I think I have to spend time to explain that to you guys.
Yeah. No, I mean, I just didn't know that. It was
Okay.
something.
So I know some students have finished, but some students are still struggling on how to plug the number into our formula to
Wait,
get
was it the
together,
same?
so we can get a better idea how to do that. So first we have to calculate summation of this different column. First, for the first column, summation t. Who can tell me? Summation t. 55. Great. 55. The second, you should be very careful to calculate summation y. Who can tell me what is summation for y? 7 7 4 0 7.
Yeah.
Okay. Everybody has in the same page?
Yeah.
Okay. Third one, ty. We first calculate ty and then sum them together. Who can tell me? Summation of ty.
47. 407.
407.
40,758.
41. 41.
Oh, you guys.
41.
300.
58.
41355.
8.
Okay.
Where?
58.
Is that 7?
Same page?
Man.
Same page? Oh, so this number gets the most votes, right?
Yeah.
Not by votes should be correct number. Okay, summation t square should be easy. Summation t square. 358.
Or 385. Yeah.
385. Okay. Okay. This part, I trust you guys because well, this just calculated. You be careful, add it together, you guys that, right? The next part, let's be introduced how to do that. So it can be a little bit complex. So first, calculate y, b, slope, summation n, summation ty minus summation t, summation y
Oh, that
divided by n summation t square minus sum t square. Pretty complex. Personality effects, we have all the number we need, right? Since you already calculated. N, who can tell me what is n?
10.
10 times summation ty, which column?
The first one.
Right? Times 41, 3, 5, 8. Minus sum t, 55, right? Times sum y,
okay.
7407. That's the numerator. Nothing hard, right? N, numerator, denominator, 10. Summation t square, you want to guess? 385. Minus sum t first, so it's 55. Summation of t 55. Then square.
T squared.
I don't do anything hard. I just plug the number we have into the formula.
Yeah.
Clear?
Following.
Clear?
Yeah, I got it.
So finally, you use the calculation to get like 7.51. Right. And then the last step is you to use the capital A equal to y bar minus bt bar. What is y bar? Mean of y, who can tell me? 700? 40.7, great. Minus 7.51 times 5.5. Finally, you get
699.
24.
So finally, our FT, you can write this down. FT equal to 699.4 plus 7.51 T. This is the formula we should use to forecast week 11, 12. Clear?
Clear.
We will finish that next week. How to forecast it. That's the one. Yep. See you guys on next Wednesday. Question again?